going to dive right into it. So again, experiments, designing experiments is for this. This is what we're doing it for. Because if we are psychologists that are trying to help people, trying to make a difference, if violent TV show watching is actually causing violent behavior, and we want to reduce this, then we can say, oh, I know how to, I have a treatment, stop letting your child watch violent TV programs. And if this causes the violent behavior, stopping this will cause this to stop. On the other hand, if that is the direction of causation, stopping this will do nothing to this. If it's the fact that children who exhibit violent behavior, that violent behavior causes them to take a look at to want to watch violent TV, you can take away all the violent TV that you want. You can reduce them down to 0 hours of violent TV per day. And what is that going to do? It's going to reduce the amount of violent TV that they watch. It's not going to do anything for this. So on one hand, you have a treatment for violent behavior. On the other hand, you have a complete waste of time to try to treat violent behavior and an ineffective treatment program. And same with this. If it's a third variable, then changing this variable, changing the amount of violent TV programs that a child watches, will do nothing to change their violent behavior. So next time we're going to take a look at how to do this. We're going to take a look at what an experiment is at its core. And the thing to remember about an experiment is that this is where we, as scientists, as researchers, set up a situation where we manipulate the causes. And that is the basic thing about an experiment. You step in there and you say, I'm going to manipulate the cause. I'm going to make things happen. So if we wanted to know if violent TV causes aggressive behavior, we would manipulate the cause. We would bring subjects in and we would say, I, as the experimenter, am going to make this group watch a whole bunch of violent TV, and I, as an experimenter, are going to make this group not watch a whole bunch of TV, and that's going to be you manipulating the causes. And that's the big difference between non-experimental and experimental techniques. And as soon as you're talking causes, as soon as you're talking causality, you need to do an experiment to get at that causality. So an experiment is research where you manipulate the independent variable, you manipulate the cause, and then you compare the outcomes of that when you measure the dependent variable. So once again, this is where you manipulate what you believe to be the cause, that's the independent variable, and then you see what performance comes out of that manipulation, what performance differences or behavior differences come out, and that is the dependent variable. So importantly here, you want to keep all your other variables constant. One of the key features of experiments is that only the independent variable changes, or only the independent variable is different between groups. You can have multiple independent variables, but those are what are different between the groups, and you want to keep all other variables constant. So that's a part of that direct experimental control, where you control every aspect of the experiment so that you keep everything else constant, so that you have only differences because of the independent variable. And randomization is one of your best tools in order to do this. So randomization, splitting subjects up into random groups, assigning them into groups based on randomization, random numbers, for example. That is your best way to keep all other variables constant. Another way to keep all other variables constant would be this direct experimental control, where you keep those things constant. So let's take a look at aggressive behavior. Let's say that we wanted to keep the groups equal in terms of what might be causes of aggressive behavior. So all we want to do is make sure that the TV watching is different, and we want to control for all other factors that contribute to aggressive behavior. We have 100 subjects, and we can measure them on those different characteristics. So what are some characteristics of a person that might be associated with aggressive behavior? Or what are some characteristics of the subjects that we might want to make sure is equal in both groups? I'll start off with an obvious one. Would we want to have one group all female, one group all males? That's a big no. No, we would not want to do that. So one thing that we could directly control for would be the gender of our subjects. We could say, all right, half of the males go in this group, half of the males go in this group, half of the females go in the first group, half of the females go in the second group. What other factors might we want to control? Yep. Age. We might want to make sure that the average age in the two groups is the same. Other things.
Maybe not change like how much playtime they get like outside of watching TV. Because if they have like a chance to like run around outside, they may be less aggressive because they get some of that energy out.
Okay, so how much do they play outside? So you can take a look at things like, how much non-screen time do they have? And we'll make sure that both groups are about average on that. We could take into account what's their involvement in organized sports and make sure that both groups have about the same number of subjects that are involved in organized sports. Anything else? Okay, so we'll end it right there. That's all an example of that direct experimental control. What's missing here is that there are always hundreds of variables that could potentially influence the aggressive behavior that we have no way of probably predicting or knowing about. So what about things like whether they own a pet, whether they have a dog or whether they don't own a dog? How about what kind of pet do they own, right? Is it a cat? Is it a goldfish? Is it a dog? How about the number of siblings that they have? How about whether they come from a single parent or two-parent household? How about if they come from a traditional or non-traditional family? How about how they're doing in school? Are they getting A's or are they getting B's or are they getting C's? How about how many sick days they had last year during school? How about whether they take the bus into school or whether they get driven into school? How about whether they had a lot of sleep the night before or they don't have a lot of sleep the night before? How about if they came to the experiment hungry or they didn't come to the experiment hungry? That's just 11 off the top of my head. You could keep going on and on playing this game. You can't measure them all. There's no way you could literally measure them all and then split everybody up along those measurements. That's where randomization comes in. Because what randomization does is it takes a subject and randomly assigns them to the two conditions, which means that all of the tired subjects will randomly, if the subject number is large enough, will randomly be split evenly across the two groups, right? You're literally flipping a coin. And if it lands heads, you're over here. If it lands tails, you're over here. And what that does is it'll split up all of the tired subjects. It'll split up all of the pet owners. It'll split up everybody on all these hidden variables. It will ensure that your groups are about as equal as they could possibly be. And especially for those things that you can't necessarily identify or can't control for. So sometimes you want to have that direct experimental control. Like you'll say, okay, I want the same number of boys in both groups, same number of girls in both groups. But other times you just want to make sure that you go with randomization in order to take care of all those possible hidden factors.